Good morning, students. Today we want to look at capital budgeting, and I want to focus in on net present value. We'll come back and do internal rate of return on a separate video. You need to go to your Blackboard, okay, and in your Blackboard there's some PowerPoint slides for this. There's also, let's see if I can find it, net present value PowerPoints. Chapter 26, then we'll do internal rate of return on the next video. Here's your classwork, which is an entire problem starting with the accounting rate of return, and it goes on through internal rate of return. These are present value tables. Now we need to take a look at this because we're not using the financial calculator. You can do that in finance. It's just easier to use the tables here. So let's take a look at these present value tables and what they are and how we're going to use them. Okay, if you pull this up, there's going to be 4 pages. Okay, present value of 1 at compounded interest. Now I'm going to talk about that because compounded interest means that you've invested money and it earns interest over a period of time. But what we're doing with present value is we're actually pulling out the interest, so we're going to call this discounted. This particular table, the first 2 pages, notice that you have time frames on the side, and then across the top you have percentages. In the middle you have an interest factor. So for instance, if you're looking at one period of time, whether that be a year or a month or whatever, at 4%, you're looking at a factor of 0.96154. Okay, 0.96154. Now, there's a complicated equation that shows you how to get that. We're not going to get into it. If you have a financial calculator, it would automatically do this for you. Now, the first 2 pages have to do if you have unequal payments. For instance, if you're investing and you're not investing the same amount every year, or if you're receiving something like a game award and you're getting different amounts every year, or even in a pension, you would use the first 2 pages. Now, when you get to page 3 here, A4, this says present value of an annuity. An annuity is a series of equal payments, and the numbers are a little bit different on this one. 1 year at 4% interest is 0.96 on this table, and they're actually larger. The numbers here are larger. If you come down, the next one is 1.88. If you flip back to the other table, let's take a look at the first 2 numbers. 0.96 is the same, but notice in the second year it's smaller. So the numbers are smaller in the first 2 tables, and they're larger in table 3 and 4, or page 3 and 4 on this. So we'll use this table. Where is it? Present value of an ordinary annuity. Okay. We're going to use this table when we get into payments that are equal. So if you're putting in the same amount of money into an investment every year, or if you're taking out the same amount every year, that's going to be called an annuity. Now, that just gives you a brief overview of the tables. These tables are also incorporated into the PowerPoint slides, just so you know, but you'll need these for homework. Now, let's go back to the PowerPoints. Okay, and we're going to look at net present value. Let's do a little review on that. We're talking about looking at purchasing large dollar value items. Maybe it's equipment, property, or doing projects that have a large dollar value. And so maybe you're even looking at investments. So you have to decide whether or not you want to purchase this equipment or invest in these investments. And that's called capital investments or capital budgeting. So these are the processes that we have used to do that. There are 4 ways: average rate of return, which I called accounting rate of return, cash payback, net present value, or internal rate of return. Now, yesterday we looked at the first 2 methods. They are much simpler. They do not involve what we call the time value of money, which is the idea that you can invest $1 and earn interest on that money over a period of time. Net present value is the most popular because of the concept of time value of money, and internal rate of return is second highest as far as usage. So this particular video will focus on net present value. Okay, again, this just summarizes the two methods that don't use time value of money would be average or accounting rate of return, cash payback. The other two, net present value, internal rate of return, do. And here's the definition for time value of money. You can take $1, invest it, and it'll earn interest. Okay, two concepts. I've already looked at the appendix. One has to do with investing a single amount or payments that were different. And the second one is if you're investing payments that are equal. Okay. Now, this is just an example that's not in your handout, but we're talking about if we invest $1 for 3 years at 10%. Okay, this is a single amount. You just invest $1. If you were to find the, if you were to go to your table, okay, and you would use your present value of $1, okay, you would want to find the 10% amount, okay. This is where they're getting, this would be present value, I'm sorry, but if we were looking at this and we were bringing that dollar back to the present, this is where you would get your information. Up here, and that's called discounting. Up here, they're talking about compounding, okay, and we don't have those tables. This would be referred to as future value, okay, so you've got a timeline here. Let me try to help you with this. You want to get a concept of what is future value and what is present value, okay? What they're doing in this table, this is times 0, is they're taking that dollar and they're going forward 3 years, 2, 3. Okay, so they're going forward 3 years into the future. The tables that we're going to be using are starting in the future and coming back to the present, okay, just so you can get an idea. We're coming back to the present. That's why they call it present value. This one that they're doing in this problem is future value. So that's why they're multiplying by 12% to earn interest, and that's called compounding. You need to know the difference between these. If you're going into the future and you're adding interest, you're compounding. If you're coming back from the future to the present, you're doing discounting. Okay, so this is the idea of compounding. And what they have done is they've taken $1. You could do it two ways. If you put the 1 in front, you're going to end up with the dollar that you had to begin with. If you leave off the 1, you're just going to get the interest. So in other words, $1 times 12% gives you 12 cents interest, which you would add back to your dollar. The $1, the 1 here, just gives you the $1 that you would put in this problem. Now, after 1 year, you have $1.12. After 2 years, you're going to have $1.25. After 3 years, you would have $1.40. And so they've taken what you had at the end of each year, multiplied it by interest, and that's going to give you the amount of money you have at the end of that year. So again, remember, this is compounding. The tables that we're using are going to be discounting, and we're going to be bringing back. So with that in mind, let's take a look at the first problem that we have. And this problem starts under the diagram we used yesterday for payback. It said capital budgeting using present value. So again, we're not using going into the future, we're coming back, which is the second example that we had done. Okay, January the 1st, what is the present value of $1.40? Now, if you notice, that's what we ended up with in this PowerPoint. Now, we want to take it back to the present. They went to the future here, okay? We want to take it back to the present, and that's what we're going to be using the tables for. So, if you're looking at 12%, okay, in this case, go to your table on A3. You want to find 12% here, okay? And what you would do is you're going to be going down to year 3, okay? Year 3. And this is the amount you want to multiply here times your $1.40. So the number of years here, 3 years at 12%, find this number and multiply that and this came from table A3. The number of years is 3, and the interest, that's I, is going to be 12%. Okay. When you do that multiplication, what you do is you come back to $1. Okay. So where the first example took you forward to the future, this example takes you back to the present. So this is looking at present value, which is what we want to focus on. Okay. Now, let's say, however, in the next example, what you've got is that you have $100. Let's draw a timeline here. Maybe you've won something. Let's say you've won a lottery. And that lottery is going to pay you, this is today, this is the present value. This lottery is going to pay you $100 in year 1. In year 2, you're going to get another $100. In year 3, you're going to get another $100. Year 4, you get another 100, and then at the end of 5 years, you'll get another 100. So this problem wants to know if we took all of this money in a lump sum rather than equal payments, how much would we have today? Okay, so we're bringing all of these back. Okay, year 5, we want to bring it back to the present. Year 4, we want to bring it back. Year 3, year 2, and year 1. So how much do we have today? Okay, there's 2 ways to do this. You can use your first table, and if you used your first table, let's just put it over here. Year 1, year 2, year 3, year 4, year 5. Now remember, this is an annuity. Okay. So if you use the first table, you need to find the 12%. Your interest is going to be at 12%. Here are the dollar amounts. The first year, you're going to multiply that 100 times 0.89, round it up, 0.893. Second year, 0.797. Third year, 0.712. Fourth year, 0.636, and fifth year, 0.567. So let me put these numbers down. The PowerPoints round them up to the third space. So let's do that. Now, when you do the multiplication, okay, this is what you're going to come out with. Let me just show you on the slides what your answer is, okay, because I don't have room here. So, coming to the PowerPoint slide, these are your answers: $89.30, $79.70, $71.20, $63.60, $56.70, for a total of $360.50. Okay, so where it looks like you're getting $100 every year, if you took all of that money right now in one lump sum, the total would be $360.50. Okay, so that's the present value. The present value of an annuity, which is a series of equal payments. The other example was the present value of one amount, a single amount. Okay. Now, let's get on to another problem. So go to your next page. I didn't quite finish this one. Let's come back to this. There's a second way to do this problem. So this is the second way. Let me finish this. Okay, that's where you're going to use the annuity table. And I know this is complicated and confusing, and I wish I could be with you. Okay, so on your tables where it says present value of an annuity, what you want to do is you want to find the 12% up at the top. Okay, here it is. Where is it? Where's my pen? There. And you want to come down 5 years. 1, 2, 3, 4, 5. So you only need one calculation here rather than doing 5. You can multiply. Notice how this is a much bigger number. You can multiply that $100 times 3.60. Okay. 4, I guess. Okay. So this one only requires one multiplication. What you want to do is on A5, you want to find I is equal to 12, N is equal to 5, and when you do that multiplication, this is going to give you $360.40, which is the same amount, a little bit off because we didn't round, $360.50. Okay, so it's close if you round it up a certain way. And this is using a different table, and it's just one calculation rather than 5. So I should have shown you that. Okay, let's get on to the problem that's in, we've already used 17 minutes. Let's go to the next problem. Now, what we want to do, we have an investment here. We have a piece of equipment we're thinking about buying, and we think it'll last us 5 years. We want to get a return. This is called the internal rate of return of 10. And this is what that machine is going to bring us in as revenue. Year 1, 70,000, year 2, 60, year 3, 50, year 4, 40, year 5, 40. So we expect to get cash revenue of 260, looks like 260,000. Okay. Now, we want to calculate the present value. Since these are unequal cash flows, we have to do it the first way using the table A2, A3. You're going to have to use that table because they're unequal. Had they been equal, you could have used the other table. So we want to look in the table that says A2, A3, and we want to find 10%. Okay, so find your 10% column in this table, and this is on page A3. Okay. And we want to multiply each of these numbers by the numbers that are listed here for 5 years. Year 1, year 2, year 3, year 4, year 5. Okay, and I'm going to round them up to the third digit. And this is also showing on your PowerPoints. Notice how they rounded them up, but I wanted to show you where they got it from. So let me come back. And we're going to do this multiplication. So in year 1, you want to multiply times 0.909. And that came from these numbers under 10% right here. And year 2, you want to multiply times 0.826. your 3.751, your 4.683, your 5.621. Okay. Now when you do those multiplications, these are the numbers that you come out with. 63,630, 49,560, 37,550, 27,320, and 24,840. Okay. Add those up and you come up with 202,900. Okay. Now, that's called the present value of the inflows, or the cash inflows. And it's the same thing that's showing on your PowerPoints. And again, the percentages, the numbers came from the 10% column, year 1, year 2, year 3, year 4, year 5. Now, that's step 1 here. So what you've done is you've done this multiplication and you've come up with 202,900. Now let's go on to step 2. Step 2 says to take that number and you want to subtract the total cost of the new equipment from it. So you want to take the 202,900, which is called the present value of the inflows, and you want to subtract the cost of the new equipment, and that gives you 2,900. Okay, and that's what they did in the PowerPoints here. And we got the cost from the problem here, right here. Now, in step 3, it says to decide whether you want to buy this project or not, this equipment. If this number, which is called the net present value, if the net present value is greater than or equal to 0, then you accept. That means you're going to have a net positive inflow. And in which case $2,900 is greater than 0, so you want to accept. And that's how you make your decision. Okay. Now there's something that you can do here called ranking a project, and for that we use what's called an index. And that's what they're talking about in this last part. It's called the present value index. Now, what I want to do in number 4 is I want to get the index for this particular problem. So, in this problem, to get the index, total present value of the cash inflows was 202,900. Okay, that's the present value of the inflows. And you want to divide that by your cost, or the amount you're investing, which would be the cost in this case. Now, if you run that through your calculator, what you come out with is 1.0145. If you're looking at indexes and you're trying to decide whether to accept or reject, if the index is greater than or equal to 1, you would accept. Okay, in this case, it is. But the key thing here is you can use these indexes to decide among several projects and to rank them as to your most desirable. So that's what this problem is right here. They have 3 proposals, A, B, and C. And they've gotten the index. You can calculate that. You could take 107 divided by 100,000. Okay, in each case, this is what they've done. They've done the division. And that's how they got these numbers. And then the one with the highest index, like this one over here, you don't want to accept this one because what's happened is it's less than 1 and the net present value is less than 0. So this one would be totally out. Okay, do not accept this. But look at the other two. You've got two that look nice. You want to take the one with the highest index. Notice the net present value on the first one is higher, but this one is more desirable because you're not investing as much. Okay, so this would be the best choice, and this one would be second best. And the other one, Project C, you do not accept it at all. And that's what they're talking about in these indexes. And they've given you that in the PowerPoints. Okay, look at the advantages here. Net present value considers cash flow, time value of money, and you can rank projects using it. Okay. Disadvantages, it's much more complex, as you can see. You actually need a financial package perhaps to do big investments like this, or at least a financial calculator. And it assumes that you can reinvest the money at a desired rate, which may not be valid. Okay, you may not get the rate of return that you want. And your homework then would be the next 2 pages on the PowerPoints. The first one has an initial investment of $42,000 and it has a cash flow of $14,000 for 5 years. Now, for this one, I would suggest using your present value of an annuity, because what you can do is you have a 10%, okay? Present value of an annuity then is this one, this page, and that's page A5. And I would go under 10%, multiply that 14,000 times your 3.79 here, okay? And whatever you get from that, you're going to subtract the 42,000 from it, okay? Now, in the next one, though, you have to compare that one to the next one, which is unequal flows. So you have to do 5 calculations on this one. And you're going to be using page A3. Go to 10%. Under 10%, you want to multiply year 1 by 0.909, year 2, year 3, year 4, year 5. Okay, so because these are unequal flows, then you want to add that up after you've done the multiplications, just like I did, and subtract out your 45,000. See which project looks the best before, and then do your index using the indexes for each one. Go back and do your index. Where is it? This formula, and that's on slide 23, and then rank them, which one's the most desirable and which one's the least desirable. Okay, and those will be on your test. I've gone almost 30 minutes, so email, text, call with any questions. I hope this is fairly clear. It's a difficult concept to have to do online, so email me if you have problems. Thanks.